Hello students, welcome to Saraswati classes. This is Dr. Sakar over here, and we will be solving the question paper ISER 2021 chemistry part. And the first question that has been asked over here is among CH3SiCl3, CH3 whole twice SiCl2, CH3 whole thrice SiCl, which one is used to synthesize a straight chain linear and which one is used to prepare a branch chain cross-linked polymer, silicon polymer, respectively. Now, the theory is basically that SiCl bonds are highly polar. Okay, so they easily undergo hydrolysis in presence of water. That means if you take CH3 SiCl3 and you treat this with water, then it will undergo hydrolysis to give you CH3 Si OH 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 and 3 moles of HCl for each mole of CH3 SiCl3. Okay, now so this is to balance, we will say 3 molecules of water being used. Now this particular molecule that you see over here, okay, this can undergo polymerization. Okay, and how that will happen? Let's take n such molecules of CH3 Si OH whole thrice, and we are saying this is undergoing polymerization. Okay, and what happens when it undergoes polymerization? Then we get this type of a unit, okay, which is say CH3 Si, all right, O O O Si CH3 O Si CH3 O, that is connected to again Si, all right, because it has 3 OH groups. Okay, not only it can extend its branching along the x direction, but also we can say along the y direction, and that type of linking we will say this is cross-linked silicon polymer. Okay, cross-linked silicon polymer. All right, so this is going to be our CH3 so on. So this is our crossed or cross-linked silicon polymer. Now, if you look at the next molecule, which is CH3 whole twice SiCl2, let's consider that one. This is CH3 whole twice Cl2, If that is reacting with two molecules of water, then it will be forming basically out here CH3, okay, and two such OH groups. All right. Well, it's better to write it in this way. This is your OH and that is your CH3 and two molecules of HCl. Now, if this particular molecule undergoes polymerization, if this is undergoing, say, polymerization, then it will form a linear unit. How it will form a linear unit and how it will look like? It will be OSI, 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 okay, O. So n such molecules, if they condense or polymerize, giving away water while these OSIO bonds are being formed, then such type of a polymer we will call this as a linear polymer, okay, of silicon. Hence, our answer will be what? Our answer is going to be ones forming straight chain linear polymers or cross-linked polymers are going to be CH3 whole twice SiCl2 and CH3 SiCl3. Okay. For the next question, it has been asked the FPCl bond angles in the most stable structure of PF3Cl2 are close to what? Now here we have to apply a rule called Bent's rule, which states the least electronegative atom or the lone pair which has zero electronegativity, let's say, are always placed on the equatorial bonds and most electronegative atoms are placed on axial bonds. Obviously, in a TVP trigonal bipyramidal geometry. So out here we know that electronegativity of fluorine, which is F, is greater than that of chlorine, which is Cl. So for the molecule PF3Cl2, okay, PF3Cl2, if we do the total valence electron count, all right, that will come out to be over here around 40. That is, phosphorus we will have 5 electrons, and for fluorine and chlorine there are 7 electrons in each, so 7 into 5, 35. That means total is 40. Whenever the number is 40, we have to divide it by 8. So if you divide 40 by 8, quotient is obviously 5, and this is indicating our steric number. Whenever the steric number is 5, we say hybridization is sp3d2, and since there are no lone pairs over here, so this is a regular structure. That means whatever will be the geometry, that will be the shape of the molecule. So here we will say it is going to be, this particular molecule will have the trigonal bipyramidal shape. Okay. Question now is, obviously if you have the P as the central metal atom, then we will draw such 5 bonds. The ones directed towards the vertices of a triangle like this, they are the equatorial bonds. Okay. And these ones that I'm drawing in green, let's say these are the axial bonds. Okay. Least electronegative atom, obviously chlorine, so that will be placed where? So we'll place 2 such chlorines in the equatorial bonds, and the rest of the positions will be taken up by the fluorine. So obviously, yeah, if I am using the blue, yeah, so this is my fluorine, that is my fluorine, and that is my fluorine. Now I have been asked what are the FPCl bond angles possible. So if this is my trigonal plane, okay, and if I think of the angles, then obviously out here this angle, say x, this will be almost equal to 120, okay, and that angle, let's say y, that will be almost equal to around 90. So out here our answer is going to be option A, which is 90 and 120 are the angles that are possible. Okay. Question out here is NiCO whole 4, that is nickel carbonyl or nickel tetracarbonyl, is diamagnetic because, and there are the following options given. So for this we will use valence bond theory. Okay, this is what we have to use. Now for that, let us first consider for the NiCO whole 4, what is the oxidation state on the Ni. Carbonyl are neutral ligands. The complex as a whole is neutral, so the value of X out here we will say is 0. That means this is basically a nickel which is in 0 oxidation state. That means this is Ar 4s2 3d8 system. So this is having 10 electrons. So basically we will call this as, within the complex, this nickel is basically a D10 system. Okay. Now if that is the case, If this is the energy for the orbitals, let's say this is the d orbital, and we are calling this as 3d. So there are 5 such degenerate levels, which is being followed up by the higher energy level, which is the 4s. That is being followed up by the another higher energy level, which is we will call 4p, and there are 3 such degenerate p orbitals, and that is my energy. Okay, now basically 10 electrons have to be filled. These are the up spin, down spin, followed by, and the 4 electrons from the carbonyl, CO being a 2 electron donor, CO is 2 electron donor, we will indicate such electrons as dots. Sorry. So there are 4 electrons, 4 pair of electrons coming from the carbonyl, because there are 4 carbonyls over here, and for that fact these set of electrons will decide the hybridization. So we'll call this as sp3. So basically this is a tetrahedral shaped complex. Okay, so VBT helps us to predict the shape of the molecule over here and the hybridization. So this is not a square planar complex. Okay, CO is a strong field ligand, that is fine, but it has nothing to do with whether the complex is diamagnetic or not. Cannot be explained by considering whether CO is a strong field ligand. Neither the synergic bonding can explain whether this particular complex will be a diamagnetic complex. So obviously we are left with the last option, which is the correct option over here, and rest being the incorrect answer for the complex being diamagnetic. So here we will say, since nickel has completely filled 3d orbital and there are no unpaired electrons, and that is the reason for which we will say that the complex is, our complex is over here diamagnetic. Okay, next we will consider, yeah, this question over here, which is saying, let me just, okay, which of the following statement is incorrect over here, and the options are given. Half-life of a zero order reaction is proportional to the initial concentration of the reactant. Half-life of a first order reaction is inversely proportional to the rate constant. Half-life of a zero order reaction is proportional to the rate constant. Half-life of the first order reaction is independent of the initial concentration of reactants. So the explanation can be done by considering the equations, which is as follows. So the equations for half-life of a zero order reaction is this one, and the half-life for a first order reaction is this one. And as we can see from the equations itself, for the first statement it says half-life of a zero order reaction is proportional to the initial concentration. So what is the initial concentration out here? The initial concentration is A naught. Okay, So it is proportional to the initial concentration. So this is a true statement. Half-life of a first order reaction, which is this one, is inversely proportional to the rate constant, which is this. So this is a true statement. Half-life of a zero order reaction is proportional to the rate constant. No, because as we can see the half-life out here, it is inversely related to the zero order, the rate constant of a zero order reaction. So this is incorrect or untrue. For the statement D, half-life of a first order reaction is independent of the concentrations of the reaction. Yes, which is true. As we can see, it is only related to the rate constant and it is inversely proportional to it. It does not have any involvement of the initial concentration. So statement C will be our correct answer in over here. Okay. And for the next one, question number 5. The time requirement for reducing 1 mole of permanganate, which is MnO4 minus, to Mn2 when a current of 2.5 amperes is passed during electrolysis. So for this, what we need to do is first, using ion electron method, balance the equation of MnO4 minus going to Mn2 plus. As we know, this is in plus 7 oxidation state and that is in plus 2. So obviously there is a difference of 5 electrons. So basically Mn from plus 7 oxidation state is undergoing reduction to plus 2. So it will be accepting 5 electrons. Now the rule is what? Whenever we have to balance oxygen, we will add water. So if we add water out here, we have to multiply the water molecule with 4 because the oxygen over here is 4. And to balance the hydrogen, we will add 8 protons on the left hand side. So for this equation, both the atom balance and charge balance have been done, and so the equation as in total is balanced. Now what we understand is for 1 mole of MnO4 minus, 5 mole electrons are required to reduce it. That is what we have understood. So we will say basically for reduction of 1 mole of MnO4 minus, 5 Faraday of electricity is needed. Okay. Now 5 Faraday means what? 1 Faraday we know in terms of coulombs is 96500 C. So 5 Faraday, what we will say? 5 into 96500 coulombs, that is the entire charge, and that is equal to what? We will say time into current. Okay, time into current, which is I over here is given to us. What is that? 2.5 amperes. Okay, and we have to find out time now. So what we will do, we will write time, that is 5 into 96500 divided by 2.5 amperes. So coulomb is basically ampere seconds divided by the ampere over here. So that is coming out to be, if we calculate, okay, that will be coming out to be, that is 5 into 96500 divided by 2.5, that is coming out to be 193,000 seconds. Okay, this is the time in seconds. If we have to understand it in minutes, we divide it by 60. It is coming out to be 3216.66. Again, if we divide by 60, it will come out to be 53.6 hours. Okay, and that should be our correct answer. Next, for a homogeneous reaction involving ideal gas, equilibrium constants at 27 degrees centigrade. So this is the temperature, 27 degrees centigrade, or we can say 27 to 73 plus 27 in terms of Kelvin, that is 300 Kelvin. Okay, for a homogeneous reaction involving ideal gases, equilibrium constants at this, all right, is given. Kp and Kc are also given as follows. If the enthalpy change, that is delta H is minus 18.4 kilojoules per mole, the internal energy we have to find out, which is delta U, that is this. Now from the equation we know delta H is equal to delta U plus delta nRT. We know also that Kp, Kc, RT, delta N. Okay, this is what we know. Now, what is Kp by Kc? 9.9 into 10 to the power 27 divided by 4.0 into 10 to the power 24, and that is equal to RT delta N. Alright, that is what we know. So what we will say, this will be 9.98 divided by 4. Alright, so that is coming out to be what? 2.495 into 10 to the power 3. That means into, we will say 1000. That is coming out to be 2495. Now, let us understand one more thing, that if we multiply 300 with 8.314, that means simply what is the value of R into T, it comes out to be 2494.2, that is almost very much equal to 2495. Okay, so this can be written as basically RT. So this total thing becomes what? RT delta N. So when bases are same, powers are equal, so we will say delta N is equal to 1. Therefore, now if this we call as equation 1, let's understand now. If we call this equation 1, we know delta N is 1. That is very much sure with us by now. So in the equation delta H, delta U plus delta nRT, the delta N value is equal to 1. That is what we have found out. Okay. So now what we will do? We know delta U can be written as delta H minus delta nRT. Okay, so let us convert minus 18.4 kilojoules per mole, and that is minus, now it will be equal to 2495 obviously joules. Okay, per mole. So that is coming out to be what? Minus 18.400 minus 2495 joules per mole. So if we do that, what we will say after the addition, it is coming out to be 20 minus 20,895 joules per mole, and this can be then written as, in terms of kilojoules, minus 20,895 kilojoules per mole, and that will be our solution for the above question. All right.